Hello. Today I'm going to start the lecture on the skeletal system. This is a fairly long lecture, and so it's going to be divided into 2 or more parts of about 5 minutes each. The skeletal system has 5 major jobs. The first job of the skeletal system is to support your body. Your bones act as an internal scaffolding to keep your organs and muscles in place. In addition to that, your skeletal system protects your internal organs. For example, if you're playing baseball and somebody hits a baseball, nice hard line drive, and it hits you in the ribs, it's going to hurt, but it shouldn't do any damage to your internal organs because your ribs, the bones in your chest, will protect you. The skeletal system is integral to movement. When your muscles contract, they need to pull on something, and the bones of your skeletal system act as a lever to create movement. Another aspect of the skeletal system that people don't often think about is that the skeletal system stores minerals. Phosphorus, but especially calcium, is stored in your body, in your bones. The middle of your longer bones acts as sites for blood cell formation. So your red blood cells, some of your white blood cells, they all form in the middle of your bones. There are 2 separate parts to the skeleton. The axial skeleton supports the central axis of the body. It includes the skull, spinal column, and rib cage. Everything outside of the axial skeleton is the appendicular skeleton. The appendicular skeleton includes all the bones of your arms and legs, your pelvis and your pelvic girdle, and your shoulder blades and your collarbones. On the screen now is a picture of a skeleton. I'm going to start by showing you the axial skeleton. So the axial skeleton is going to be in red here. My handwriting is awful, but that does say axial. And the axial skeleton is the skull, so this whole area here, the spine, and the rib cage. Okay, so the axial skeleton is simply the mid-axis of the body. The skull, the rib cage, and the rest of the spine. Compare that with the appendicular skeleton. Now I'm not going to write that because I think it'll look awful. The appendicular skeleton starts with your collarbones. It includes all the bones in both your arms. It includes your pelvis, excluding the part in the middle where your spine is. And it includes all the bones in your legs. Now, if you had to make a guess, where do you think that the shoulder blades would fit? Is the axial or the appendicular skeleton? Well, if you said appendicular, you would be correct. Your shoulder blades, which are right back here, are not part of the main axis of your body, and therefore are part of your appendicular skeleton. Heading back to my PowerPoint here a second. Last thing we're going to cover today is the basic structure of the bones. Now, bones are simply a living network, a solid network of living cells and protein fibers that are surrounded by calcium salts. The outermost layer of a bone is the periosteum, and that's simply a layer of connective tissue. Immediately underneath the periosteum is compact bone. Compact bone is a very dense, very strong layer immediately underneath the periosteum. The Haversian canals are tubes within compact bones that contain blood vessels and nerves. Some bones also have spongy bone sections. Now, spongy bones are less dense than compact bones, but they happen to be very strong because the cross linkages of them act like the linkages of like steel beams in a bridge. They tend to be found in bones near joints, and the advantage to spongy bone is it reduces the mass of the bone without sacrificing strength. In the middle of each bone is bone marrow. Bone marrow is a soft tissue within a bone. Red marrow makes red blood cells, some white blood cells, and platelets. Yellow marrow is fat storage. The last thing we're going to talk about today are the three different types of bone cells. You have osteocytes, which are mature bone cells, osteoclasts, which break down bone, and osteoblasts, which build up bone. Thank you for listening to this lecture. I will continue the rest of the lecture in a different file.